Water uses energy, energy uses water. Here's the steps again that I was just talking about. Fuel production, extraction, refining, hydropower, fuel production, thermoelectric, and then on the other side, extraction, drinking water treatment, distribution, wastewater treatment. So it's inextricably linked. You can't have one without the other. And there's a third player in this, which is, of course, food production. Now, you are very accustomed to thinking of the energy output of oil, of gas, of hydrocarbons. Do you know that it takes 1 liter, this isn't quite a liter, of water to make a calorie, also an energy measure, of food? 1 liter per calorie. And so if you and I eat something more than 2,000 calories a day, that means we need 2,000 liters of water. When the population of the world moves from 6 billion to 7 billion to 8 billion, and people want to eat more and more protein, they want higher calorie food, and so at the same time, we have more demand just to create normal, ordinary cereal type foods. But then that demand goes up and up because people want food with higher calories, more liters of water. And so therefore, in places where energy production and food production are both in a tight situation vis-a-vis water, you find things like hydroelectric plants having to shut down during droughts. You find that cooling installations on energy projects can't be operated because of a shortage of water, because the water is supposed to be going to food production. And this is what we're calling the nexus. And all this says is that with 2 billion people on the planet, you don't feel very much the pull between energy, food, and water. As that amount moves, as that number of people moves up and up, as we move in more and more cities, then the pull between water use for food, energy, and water gets everywhere quite different, and in some places really quite acute. This is why you have to start thinking about how you're going to allocate water, because it becomes the determining factor as to whether you can proceed with more energy installations. And this is particularly real when you get to bioenergy, that our first biomass that our first speaker was speaking about. The 1 liter per calorie is very real. When you think about a cubic meter of water, which is, this is just about a cubic meter high, so imagine that in a square, because you're more accustomed to thinking in terms of barrels and gallons. But you think of a cubic meter of water, it takes that much to make 1 kilo of rice. You surprised? It takes 2 of them to make 1 kilo of rice, and it takes 5 to make a kilo of chicken, and about 7 or 8 to make a kilo of beef protein chicken. And so you begin to see that as our demand for more food and more high-calorie food goes up, it pulls the water bill up and up and up. As our demand for more energy goes up, where that energy uses a lot of water, it pulls that water bill up too. So when you look at how that triangle operates in MENA, the MENA nexus, the growth, very high demographic growth. The region is poised to double population in the next 40 years, which will mean more demand for food, more demand for energy. Increasing living standards pushes both of those up. Food has a high level of import dependence. Jordan is as high as about 80%. And the importance of the agricultural sector is huge as a water user, but it's also very important as a population stabilizer and for employment. And after the events of the last 2 months in this region, we know that employment is an extraordinarily sensitive issue. And so therefore, a cavalier decision simply to use more of the water for municipal purposes or energy purposes would have extremely sensitive and difficult consequences in many regions, but particularly in this one. There's our friend saying a calorie equals a liter of water. Water is not in good supply in this region, everybody knows that. With 5% of the global population, you have only 1% of the world's renewable freshwater resources. And 60% of the water in the whole MENA region is transboundary, which makes the management of it quite tricky, particularly when there's troubles in the neighborhood, which there quite often is. So you've got the highest per person freshwater extraction, using a whole 75% of the resources, and a decline coming in the years ahead with climate change and climate variability.